Hey guys, welcome back to SudokuManiacs. Sorry, I had some system issues yesterday, so could not put up the second video from the Notify series, but hopefully things are fine now. So we'll go ahead with our series on the Notify Sudokus. So earlier we had seen the Notify arrow Sudoku, and today we are going to have a look at a Notify diagonal Sudoku. Now it is like your regular diagonal Sudoku, except that on one of the diagonals, one single 5 will replace another digit. So basically we'll have two digit 5s on one of the diagonals and the remaining would be 7 unique digits. Now we don't know on which diagonal this 5 will be getting placed. So that is part of our solving to identify. And believe me, this was really a very nicely crafted diagonal Sudoku with very narrow paths. I won't call it too narrow a path, but it uses the diagonal, what do you say, techniques in a very nice manner. So without wasting much time, let's go ahead. Like I always say, always start a variant like a classic. Exactly. But here you have to be even more careful because we cannot use the diagonal constraint as we don't know which of the diagonals is the incorrect one. One of the diagonals will have all the digits 1 to 9 on it. The other will have only 8 digits with the digit 5 repeating twice. So to begin with 9, 9, 9 can't be here. So this would be a 9. 1 cannot be here, cannot be here. So that's the only place for a 1. Which gives me the 8 here. 7 cannot be in row 8, so that's 7. Remaining are 2 and 3. So that's a 2 and that's a 3. Okay, 1 4, 1 4. So this will form the pair of 1 and a 4 here. And the remaining two digits on column 4 are 2 and 7. So that makes this 7 and a 2. 3, 6 and 8. 3 and 6 both cannot be here, so that's an 8 with a pair of 3, 6. And the remaining digits here, column 6, are 6 and 7. So 259 makes this 5, 9, 259, 259. Now if this were a normal diagonal Sudoku, I have a 1 in box 1 and a 1 in box 9, which are not on the diagonals. So that would force me to directly place a 1 here with a 4 here, correct? But that would be possible if this was a normal diagonal Sudoku. However, I cannot place the 1 here because for all I know, the top left to bottom right diagonal might be the diagonal which has the two 5s and the second 5 has replaced the digit 1. So for that, we do not use the diagonal elimination technique for now. So we'll continue like a classic. So okay, missing numbers are 4 5, 4 5, and same way row 8 we have a 5 6 and a 5 6. Now at first glance this gives me an X-wing on the 5s, right? Which means the digit 5 cannot repeat on in column 2 and column 8. But how does that help us here? In this it won't obviously, but let's park that to the side for now and see how we can proceed. Another thing that I noticed when I look at the placements of these 5s on the diagonals is that if this were a 5, oh, sorry, if this were a 5, this would be a 4, this would be a 6 because the 5 has been eliminated, and this would become a 5, which means I'll have the two 5s on the same diagonal. But if this were a 4, this would be a 5, which would make this a 6 and this a 5. So when I look at these 4 cells on the two diagonals, irrespective of what the positions are, the digit 5 will occur on one of the diagonals in row 2s and 8 only, right? But we still have to identify excuse me, the weather's a bit cold here, sorry about that. So but we don't know which of the diagonals is the incorrect one, but we know for sure the digit 5 will be on the same diagonal, right? Having said that, it again brings me to the central cell, which is row 5 column 5, which again has pencil marks of 5 and 9. Now we know that the two 5s will be in the opposite ends of the same diagonal, whichever one it may be. What that means is I cannot have three 5s on the diagonal, right? If this were a 5, I will have three 5s in whichever diagonal is the incorrect one. So I can safely eliminate the 5 from here, place the 9. So we have used the diagonal constraint as well as the rule of this notify stating that there will be exactly two 5s on one of the diagonals. So we eliminated this. So we can eliminate the 9s. So we have a pair of 2 and 5. And for row 5 we have the pencil marks of 4 and 5. But still we are not able to identify which is the correct diagonal. So let's go ahead and see what else can we find out. Row 1, 1 and 2 not possible, 3 is possible, 4, 5, 6 is not possible, 7 is possible, 8 is possible, 9 is not possible. Alright. 1, 2, 3, 4, 5 are not possible, 6 yes, 7 is a no, 8 is a yes, 9 is a no. 1, 2, 3, 4, 5. Oh, 6 also is not possible. 7 is possible. Again, 8 and 9 are there in the column. So that is a hidden, or rather a naked single 7 that is possible here. So we can eliminate that. And since we have a 7, this will be a 6 and a 7 here. The reason being, it's only the 5 which is going to repeat on the diagonal. The other digits cannot repeat. So since we got a 7, we can safely eliminate the 7 from row 4 column 6. Now that we've got a 6, we know for sure this will be a 5, that's a 6, that's a 4, and that's a 5, and we have identified the incorrect diagonal with. So the top left to bottom right diagonal is your correct diagonal, which will have 1 to 9 digits. So we got a 4, that's a 1, and that's a 4. Missing digits on this diagonal are 2, 3, 5, and 8. Okay, we got a 3 here. 2, 3 is possible, 5 and 8, all 3 are possible. Okay, here 3 and 8 are not possible, so this will be a 2, 5, and here 5 and 8 are not possible, so that's a 2, 3. Okay, now on the other diagonal we have 3 places available, but the missing digits are 1, 2, 3, and 8. So 4 numbers out of which 3 will be placed, and 1 is the digit that has been eliminated by the 5. So this is a 2, 3. So this will be a 1, 8. I have a 1, 8 here. So this is a 2, 3. 1, 8. Oh, 2 is also there. So this has to be a single 3, which makes this a 2 and a 3. So this is an 8. 3, 5 is, sorry, 3, 8 will be out, and that's a Eeks. I have some butterfingers today. So we got all the digits on this diagonal. Now from here, this can be either 1 or an 8, depending on which one is eliminated. Last two digits, 4 and 6, we got a 6 here, so that's a 4, that's a 6. So this becomes a 5, that's my 4. Missing digits here, 4 and 7. Okay, 7, 4, 7, 3, which makes 6, 3, and a 6 here. Column 1, 3, 5, 3, 5. Column 2, 6 and 9. Oh, we got a 6. So that's a 9, that's a 6. And the remaining two are 7 and 8. So we got a 7 here. 8 and a 7. Okay, 148. So that's 48, 14, 59. Okay, we have a 9 and a 5. So 9, 9, 9 cannot be here because you already got a 9 in row 4. So this is my 9. So that's a 1 8 pencil mark, right? But we have a 1 here, right? So this is an 8 and that's a 1. So in the incorrect diagonal, we see that the digit 8 has been replaced. Now that we have got all the 4 diagonals, I think this would solve like a classic Sudoku. Column 9, missing our 1 and 2. We got a 1. So that's a 2, that's a 1, which makes this a 5 and a 2. Oops. 5, 2, 3 and a 5, 3 and a 4. Yep, the system tells me the solution is correct. I really like the way the X-wing formed, and using that we were able to identify the positions of the two fives and eliminate the 5 from the central cell, which is row 595. A really class puzzle by Henning of Denmark. We have 3 more of such naughty fives available with us. And if you want to try this puzzle out, I have added a link in the description of the video. You can go ahead, play online. And if you did enjoy the video, do like and share it with your friends. Let us know in the comments what you thought of the puzzle, because I'm sure Henning would also love to hear feedback from you all. And tomorrow I'm going to put up the Naughty 5 Even Sudoku, the third of this series. And believe me, that also is a fun Sudoku to solve. So till I see you tomorrow, happy solving!